Howdy everybody in YouTube land. What we have in front of us today is a box, but not just any box. So someone has reached out to me and donated a computer to the channel, and this happens to be a Toshiba T1000. Now, he was watching my earlier video on the T1000 SE, which I still need to get some work done to, but he reached out to me, said he had this thing, and he said that it was partially working. He recapped it, and then it doesn't work at all anymore. So he decided to just pass it on to me to see if I can figure out what's going on with it. So now we just got to figure out what mysteries lay inside and determine if we can recover the situation or what's going on. Now, Toshibas are kind of a pain in the ass to me because I've got a T1200XE that a different person has shipped to me, which is in progress, and that's not a donation, that's a repair. And that power supply is a complete mess, and I couldn't fix it. So he sent another one, which the power supply was in slightly better condition and half the components weren't eaten off the board, but it won't fire up. So yeah, I got to figure out what to do about that. Now, I don't want to get too much detail on that because that'll be in an upcoming video, but in meantime, let's take a look at this one, which is the subject of this video. So we got to figure out what we got going on inside. So how about let's do that? Alright, so let's try something new today. Look, no hands. So I finally got a tripod along with this DJI gimbal thing. So if I move this tripod, it won't. It should have a little bit more optical stabilization. So I can probably bring this up a little bit so I don't have the legs this wide, because this tripod takes up basically my entire floor. So I can't like use it while I'm working on stuff because there's just no room. So now I use the gimbal adjustment and I can adjust the camera ever so slightly. So there we go. We'll just do it that way, I think. Alright. Looks like I got an eBay message. What are you? Anyways. Okay, let's see what mysteries lay inside here. Oh, wow. It's still in the original bag. That's kind of impressive. I wasn't expecting that. No. I wasn't expecting that at all. No. Move you out of the way. Let's see what we got going on inside here. So there we go. I need to adjust you downward. There we go. Now, what is in here? Oh boy. Toshiba T1000. We got some caps. So the problem with this, okay, is when you're buying capacitors to recap 2022. So this was over a year ago. The problem when buying capacitors to recap a power supply, especially a switching power supply, you kind of need low ESR capacitors in certain parts of the circuit. Now, in some cases, you can get away with standard ordinary capacitors, but there's a lot of cases where you can't. So just keep that in mind when recapping. So that might be some of the problem. What in the world is this? It's a vintage cable. DB25 to DE9. Holy crap, this thing has all the manuals. Wow. That's kind of impressive, actually. Alright, let's see what else we got here. Another manual. Oh, that's a spiral bound, but it's a hybrid. Weird. T1000 personal computer. I've never had one of these. I've never worked on one of these. The actual the original release T1000. So I've never really had one. Anyways. So yes, it was a donation to the channel, and I appreciate it, as always, because it's not very common I actually get donations, but when I do, it's unexpected, you know, so I enjoy it. What in the world is that? Some kind of composite cable. Let's see, what do we have here? Sidekick. The desktop organizer, just a keystroke away from Borland. Exceptional care and extended care manual. Toshiba American. I wonder if that's still good. And then you. Let's see, when does this? 1984, 1985. Vintage. Oh, there's the diskette. And it's a 720K double density disc, as indicated by the lack of a hole. Alright, that's cool. Let's kick you off to the side. And actually, I'm going to start putting this stuff back in the bag, because this is not important for the discussions of trying to figure out what's going on with this machine. So, but it is nice and awesome that I actually have the manuals to this. So I wasn't expecting that. I really wasn't expecting the guy just to give it to me. I figured he was just going to send it to me for a repair, because I would have done a repair on it and sent it back to him. I don't mind, because I got enough of this stuff, you know. Anyways, wow. What's in here? I don't know. Holy crap! This thing has the original power supply. This is. I don't know what to say about this. This is rare to be in this kind of condition. 9-volt DC, original power adapter. It's an original. It was probably kept in its bag its entire life. There's almost no yellowing whatsoever. There's some wear, you can see there, but that's to be expected. So that's fascinating. Still has its original floppy drive. No expansion card, but it's got the composite jack. Now, he stated in his email that it used to work, but it would only output on composite. And then when he recapped it, it quit working entirely. So I'm going to assume that he made a mistake during the recapping process, but I'm sure we shall find out soon enough. This thing's in amazing condition. Oh, hoo, 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 hoo. Don't smell it. It smells awful. And anyone that knows what recapicides look like knows exactly the smell I'm talking about. Ooh, well, that's got to get restuck. But I'm not surprised, because I think there's a screw hidden there, and you got to take that out in order to get to that screw. So, rubber dome, but mechanical keyboard. The screen has got vinegar syndrome, so that's an issue. We're gonna have to replace that polarizing film. So this was probably triggered by either bad storage conditions or the capacitor electrolyte outgassing. And because I've noticed with some laptops, if the capacitors are outgassing, or if there's a battery in here that's outgassing really badly, it will attack the PVA material that is made out of. So that's a problem. So yeah, we got vinegar syndrome we got to deal with. I have a polarizing film that I can probably use on this, maybe. Because my previous videos, I was working on the OmniBook 300 series, 425, 430, and I got a display with the same problem, so I bought a film to replace it. So we're going to have to do that on this one too as well. I don't like the way that sounds. Anyway, so I gotta set you aside. The display is minuscule. The display fault is minuscule because that's really secondary to what we have going on. The more important thing is fixing the system. Now I'm going to leave this out, well, in this bag, because I'm going to run it from the bench power supply. So for now, I'm going to set you off to the side. Okay, now we have our Toshiba T1000, and we have a set of capacitors right there. Okay, so now in order to work on this thing, I have to move the tripod out of the way, because the tripod is literally taking my entire floor space for where my chair sits. So I can't, that's why I can't use a tripod while working on stuff as much as I want to. What I need to do, honestly, is I'm going to disconnect you from the tripod. What I need to do, because here's the tripod, I need to mount something up on this wall and have like a boom camera or something. But anyway, so I have to move you out of the way. I can probably like leave you there or something, because I don't know how well that would work like this. Because, oh, that might actually work fine. If I just do you there, like that. I suppose I can do it that way. I don't know how well that's going to work, but I could probably do it that way. So let's try that on for size and see what happens. And actually, what I need to do, because otherwise the battery is going to die on the camera, is I'm going to take you, because that doesn't have enough amps or voltage, or not voltage, current output to run the phone to provide proper output. However, the gimbal is preventing me from whoops, wrong way. I'll get this gimbal figured out eventually. Alright. We'll see how that works. How's that? Ow! Alright, so what I need now is I need my screwdrivers. I need to get in here and figure out what's going on. Now, unfortunately, I can't see the screen because you're way up there. So, alright, now, I'm not going to try to plug this thing and turn it on. I'm actually just going to take it straight apart and determine what we've got going on that way, because the issue is I don't know what's been done to it physically other than what the email claims has been done to it. So I need to just do a quick inspection for myself to make sure there's no blatant mistakes, or maybe a capacitor soldered in there backwards, or a mis-solder line. You know, possibilities are endless. Anything like that can happen. Lord knows I've done it myself. I've blown so much stuff up by accidentally soldering something in wrong or backwards. You know, we're only human, right? So things like that just happen. So I've never taken one of these apart. Not this particular model anyways. So it's going to be interesting how this actually works. But yeah, Vinegar syndrome. Okay, I see what we got to do. I see what we got to do now. Now, apparently, from what I understand, these will not run without their original battery. These are like the Macintosh Portable when it comes to that. I bet there's a way to make it run, but there we go. Okay. That's out of the way. Move you out of the way. I've got literally I got no room in here at all. I just don't, so. Okay, so these do not have a hard drive. No, they do not. So, alright, let's figure out. I wonder if you can actually see the meter up here. Can you actually see the meter? Actually, you just can. That's good. That'll make life easier in the future when doing repair videos because you can see what I'm doing. So now I'm going to check the voltage on the battery. 1 volt, so it's deader than a doorknob. He did say to inspect the battery because he said he didn't do that great of a job rebuilding the battery. So, I don't know. Oh boy. Yeah, this is awesome, but fine. So this is a 4.8 volt battery. So 1.2, 2.4, yeah, 4.8 because there's 4 NiCad. Now, I don't know if he used NiCad or if he used nickel metal hydride because you can't really interchange them. So the charging specs are slightly different. You can go, I think the way it works is you can charge one with the other but not the other way around or something like that. So got that. It's got that smell. So it actually doesn't look bad. It's not terrible. So honestly, I don't see much of a problem. So alright, well let's take it further apart and see what we have. Because it's going to be all about determining what we have to do from here. Let's see, who made the keyboard? I don't know. I'm not sure who that company logo is. Alright, so set you out of the way. Let's take you out. Looks like a traditional standard floppy drive. Like a Citizen drive. Nothing special there. Actually, no, you're the same as over here. I'm trying to keep similar screws grouped together. Hiding. I don't see a real-time clock battery in here, so they must be relying on the main battery to keep the real-time clock. Yeah, so I just removed you. What are you doing? Oh, I see why. There. Doesn't use a belt. Traditional floppy drive. Well, it's the 26-pin Citizen standard, which they miniaturized this on the modern laptops we saw later on throughout the 90s. So okie dokie then. There's an expansion card here, or at least a plate, but I didn't see an actual expansion header. So does this thing not have an expansion bus? Well, unless it's these, because we have this. That's a RAM expansion. So we have a RAM expansion here. We have the keyboard there. We have the floppy drive there. We have modem there, and then I don't know what you are. But as far as I can tell, there's no expansion bus. So without an expansion bus, you can't do like XT IDE or something. Well, the good news is there is a ROM. The main BIOS is here. And then we have, that's probably, presumably, the DOS ROM. So if the ISA bus or XT bus is broken out somewhere on this board, you could replace this with an XT IDE ROM instead and connect you wherever the expansion bus is. I'm not for certain on this particular model. So my guess is what this expansion socket here is for, this slot, is for a modem to go there, and it just plugs in here. But the fact this is wide makes me think, see, it's an 8088, so that makes me think this is the XT slot, the 8-bit, you know, ISA slot, before ISA was actually a thing, because ISA is 16-bit if I recall. You. I'm going to get you out of here. There we go. Ooh, buddy. This is bad. Yeah, this is not good. So some of these traces got myrtleated during rework. When it comes to redoing these circuits, you have to be incredibly careful. Yeah, you've got to be super careful, because I see the problem right now. I see it. I see it right now. I don't know if you're going to be able to see it in the camera, but you see this? This oh, trace is broken. You know what? This thing just kind of like flip-flops. Stupid. The gimbal shut down. Yeah, I'm not going to be able to use the gimbal with this. Yeah. Alright. Try this again. I don't know how much of that worked. This is the first time using a tripod and a gimbal, but yes, if you look here, you can see where there used to be a trace there and it's broken off. This one got coiled up where this capacitor is, so that is likely why it doesn't work anymore, because that's got to be fixed. And that was caused by the person reworking the board with new caps, is just breaking that right off. So that is to be patched. That's the only thing I see right away. Now, other than that, there are some other traces in here that are just completely just screwed. So what I'm going to do is I'm going to start working on all of these. I'm going to start inspecting all of this under a magnifying glass and seeing what we got. There's some crud down there too. So yeah, let me get a magnifying lens out and I'm going to take a look at all of these connections. Alright, so I went ahead and washed the board, and there are several things going on with this. So where do I start? So first off, we have this broken trace here. That's one. And that was caused by trying to desolder it. We have another one that's broken here. So that's got to be patched. So there's two there that have to be patched. And then we have Another one here that's broke. You can see the tail left, but it's not connected to this point anymore. So that's got to be fixed. And there's another one somewhere up here. Broke it there too, you can see. So yeah, there's multiple when you're unsoldering. So the way these boards have to be done is these get so soaked the leads get corroded. So what you have to do is you have to rip the capacitors out of the board. I know that sounds harsh, but before you do any soldering, you got to rip it out of the board and leave the lead behind. So that way you can unsolder the lead by adding fresh solder and working the corrosion, fresh solder, and then pull the lead out by dangling a weight on the lead while soldering on it, and then it'll just fall out so you don't run into this problem. And then you can go and clean the holes out with a desoldering gun, right? But that didn't happen here. And also what makes it worse too is this one right here, the plating is completely missing out of the board. So I can move this pin around. It's only connected by this point. I don't know if there's an internal power plane that this has to connect to or not. Because if not, then, or I mean, if there's a internal connection here that's broke now, this board's never going to work again. Not without trying to figure out where it actually went, and I'd have to have a working board as a basis of reference to do that. So we've got a lot of damage here that we have to attempt to patch up and hope we can bring it back. Because if not, we might be up shit creek without a paddle on this one. Because I need we're already up shit creek, but I need a paddle so I know the reference of all that. So in the meantime, what I'm going to do is I'm going to patch up all of these connections and try to attempt to power up and see if I can make this thing work. Alright, so I took the gimbal off because it was screwing me over pretty hard. Because, well, right now it's charging, but if I leave the charger connected to the camera, this thing can't stabilize and it'll just shut down. It's just, anyways, yeah, it's a problem. So now you're gonna have a lot of this. So yeah, unfortunately, woo. Anyways, so yeah, there we go. All right, now we're gonna make this thing work to some degree, somehow, or at least try to anyways. So first off, I've got to go through and fix all of these solder joints that are not properly done, because it's oh man, I can smell the cat goo. Yeah, this is bad. This is really bad. So that's missing its solder, so let's fix that. I can smell the capacitor junk. So let's fix that. That one was shorted out to the pad next to it, which shouldn't have been done. There's a via there. See, I need a working... See, that one was blobbed over to the trace next to it, so that's never going to work. Now I have to patch you up, but before I do that, so I'm just going through right now and literally fixing this mess. There we go, so that's fixed now. Blobbed over. So we have that one, so I gotta fix you. Solder crust. It's fun, so it's definitely, whew, yeah, it's great. I love it, but it's the only way to make this thing work properly. So we got another one that's all broken away over here, got another one that's broken away here. Oh yeah, there's no pad left on this one. Rip the plating right out of the board. And see, this might just be done. So that one has got the plating ripped out of the board. So what I might end up having to do is I might have to go on eBay, buy another one of these that are in like rough shape, and steal its motherboard. Because this one's a bit bad. I'm not even concerned about the battery at this point, because we got much deeper problems. I mean, I get it. I definitely get it. When you're learning to do recaps and you're doing this kind of work, right? You got to start somewhere. You got to learn, right? And I am totally not against people learning to do their own recaps and learning things like that, because ultimately that's the only way you're going to keep this kind of stuff going, right? But the Toshiba series is not the machine to learn to do that on, because these things are advanced. This takes an advanced skill set to properly do. And this is the reason why, because the traces are so narrow, they're packed together. This is a multi-layer board, so there's a lot of issues when it comes to that alone. So, because prior to the recap, the display didn't work. So who knows, besides the already new broken traces, there's probably another broken trace that was eaten away by the capacitor plague. Right from that point forward. So that's the issue, is we don't even know what the original fault was besides recapping. So we've got to fix all of that first. So yeah, I have my concerns. I definitely have my concerns, but well, you don't know until you try, right? I need to check that connection. Is this an issue? Yeah, they're not supposed to be connected. That's what I thought. It was blobbed over. So that was shorted. So we can't have that. We have U, which goes up here. That's fine. We have U, which goes over here. Which it's kind of hard to tell because it goes to a via. Got U over here, it goes to a via. You're good. You go over here. You're good. So that's fine. You're a diode. It's fine. That's not reading anything. Oh, it's because it's an NP or PNP. That's why. All right. Okay, that one's fine. All right, so I need to patch out. Yeah. Which to do that, I need you. Eventually you get very good with your hands when you're doing this kind of thing. Because the problem I have now is I don't know if this is going to solve my issue. Because the plating is gone on that board. It's a problem. Fixed. That one I don't know. That one's fixed. That one needs to be fixed. Okay, so what we have to do there is we have to patch you. That one's not soldering because it's full of capacitor goo. That's the fun stuff about this. Yeah, every single one of these Toshiba T1000s need caps. The entire early T1000 line, period, needs caps. The T1000, all the variations of the T1000, the T1100, the T1200, the T1600, they all do. Every single one of these. So anyways, that's patched. Let's see, we have you, we have you, we have you. You're not, I'm not sure. There's two here. Then we have one here, which is done. One over here, which I need to test. It's fine. Figure out which ones are you or ground. Yeah, that's... Let's figure out what you actually are. That doesn't feel right. It is ground, but I have a suspicion the plating is about gone out of the board. So it's a very high impedance ground. Oh, so we have you, which I already checked. So we've got 5 caps that were replaced. There's only 5. But these are like the most stubborn capacitors to get out of these boards, because this is a multi-layer board. There's a huge ground plane in here, so it's not. Like I said, these are not the best ones to cut your teeth on first. So yeah. I do not have a CGA monitor. I don't have anything composite on the top of my head at this moment. So I think what we're just going to do is test it this way. So what I like to do is I like to make my life simple. So first off, what I'm going to do is make sure the ground is still ground. No. Neat. Okay. Yeah, I don't have a schematic, so I'm going to do this a different way. Now, what I need now is, I think it's 12-volt power. Again, because I'm pretty sure it's over here, so power goes on that side. Okay. Battery's charging, so we have that. Power's on. Hey, how about that? There we go. Now, next part. You know what's coming next, right? The screen. Because I don't know if this thing actually works. We're going to find the hell out, aren't we? Yep, screen's on. It's got some bad connections in the panel, but screen is on. Yeah, see all these lines? We gotta work on this panel. Yeah, I know what that is. But look, it's working. It's working. Wow. Well, I shorted out my wires. It's working. Wow, it's working. Oh my god, I'm shocked. I mean, not really, but it is now January 1st, 1981. All right, there we go. So, that's all we had to do. We had to patch up a few mistakes on the PCB that the original owner had done, and it's real easy to do. It's real easy to do because if you're not paying super close attention on how that stuff works, it's not hard to screw something like that up, right? So anyways, the screen works fine, except you can see there's some lines in here. We've got a bad polarizing film, so that's gonna have to go because you can see the degradation starting right there. So we have that, but yes. All right, so what's next? What's next? What's next? I think we need to, we need to take this panel apart. It's what we need to do next. How do we go about doing that? I see a screw here, and I see a screw here. I also see a screw behind that. So, all right, we got some zebra strips we have to pay attention to because someone's had this panel apart. Because if you didn't, we wouldn't be having this issue here. So, I think we also have a dead column driver. Well, luckily these displays, they use discrete ICs, I'm pretty certain. So, anyways, it's working. It's working, it's working, it's working. I love it. Yeah. Alright, so I'm going to set you out of the way for right now. What I do want to do is I want to see if this battery is holding a charge. It is. It is charging. Alright. There we go. So now, with that out of the way, shut you off. I'm going to leave you alone right now. So the circuitry is working. We're working fine there. Oh God, those resistors are warm. That was stupid. Alright, so now we need to get to this screen because this screen is completely just trashed. That doesn't stick anymore. Not surprised. Oh wow, that screw is mangled. That's... yeah, no. This screen's been apart before because someone's been screwing around in here. Not a big deal. Let's just hope that it's easily correctable. You know, because with how bad the screen's got lines in it, I'm not surprised. For a machine that's in amazing condition, there's a lot of electrical gremlins going on in here. But it's vintage. So yeah, it's actually not really that yellow because you can look inside and, you know. So the fun part is... trying to get this thing out. Because I don't know. Because I could have sworn the way this actually works is... yeah, you can see where someone's been in here because there's pry marks. Someone was definitely prying out, doing the same thing I'm doing, basically. Trying to get the screen out. Whether they were successful or not, I don't know, but... me work at this a bit before this video gets way too long. Alright, now that I got it all taken apart, it's on again. So, like I was trying to show before, we got a couple of problems we have to deal with. One, we've got all these lines, probably from bad zebra strips in here, but more importantly, we also have, oh, that's interesting. Probably went to sleep. Yeah, it did. So we got that, but then we have the vinegar syndrome we have to take care of. So because we got to take this apart anyways to get to the vinegar syndrome and work on the zebra strips, I think we should peel off this film and at least work with that first. But that's what I think we should do, is because if I don't know, it's catch-22, because if I pull all this apart, it's been apart before, I can see the scratches. So someone's been tinkering with this before. But the important thing is, if I can't do anything about this polarizer, or if I break the screen or something stupid like that, then really doesn't matter what we do, right? So I think what we need to do is we need to peel this thing and take this thing apart and see what we can do with it. Yeah, let me tell you, this stuff smells absolutely wonderful. So I'm peeling it apart, getting this old film off. So the zebra strips, this has been apart before, which is why there's lines in it, because the zebra strips have crap all over them. There's a scratch on the PCB right here, or someone got a pry tool up in there, so that's a problem. But the biggest thing is right here. This is the most disgusting, vile smell I think I've ever encountered. It's just bad. What I need is a little bit of heat, I think. The only problem is I don't want to damage this panel. Because trying to find another one of these without, buying a complete another unit, more difficult than it appears. So, oh god, it smells so bad. Oh, dang it. Okay. Have to pull out the big guns, because this is just, yeah. Anyways. Oh god, that makes it so much worse. Too hot. It doesn't really help that much. I mean, it does, but it doesn't. Whew. Yeah. screen's getting too cool too quick. I feel like I'm working with color roundy cataract surgery with this. Oh, I need nose plugs. I need nose plugs. This is so bad. Oh my god. Oh shit. I can't with this. Wow. Now I know why they call it vinegar syndrome. Because, yeah, buddy. Christ. Well, the good news is I don't want to cut this because I need this as a template to determine, okay, how am I going to measure this out, you know. I don't know what the actual angle is specifically. I'm thinking it's going to be 45 or 135, something along those lines, because it's used for, you know, polarized lenses and sunglasses and things like that, because it tends to be more compatible with it. Okay, so now I need more heat. There, it's off. Film. It's got a bluing to it. Man, it does. Wow, so this is a blue style polarizing film. Okay. So this is what makes, you know, look, this is what makes the text blue, because it's got this blue. So that means the replacement film, you can't get this stuff anymore. So the replacement film is going to make the text black, right? It's not going to be blue anymore. It's going to be kind of a black. Yeah, that's about right. Makes sense. Because that goes, what's the 135 angle? Actually, it might be 90 degrees. It might be. I don't know. Anyways, point is, we got it. So, I got to get the goof off and clean all of this old crap off the panel. That bristles. That brush is right. Not really, yeah. Oh well. It's trying to get this goof off in other areas, because the last thing I want is to get it into the zebra stripes, because that'll make it better. Oh yeah, that's much better. I'm not sure what dissolves this adhesive except for things like this. So I'm going to let that sit and absorb in, and we'll get back to that later. Alright, so this film here is from a company called 3D Lens out of China. They got various different sizes. You can get matte, you can get gloss, semi-gloss. There's a bunch of different versions. You can even get their replacement transflective film that you see there. That's on the other side of the glass. So you can actually get all of this stuff. So I think I got a matte, and this is a standard one. It doesn't have the blue tinge to it. So it makes the LCD appear to be green like the more traditional style. So it doesn't have the blue look to it. It's more of a green look, but the other thing I got to figure out is which way, because if we look at it in the camera, that's like fully negative, and then you can get green, and then you can kind of make it a different color there, and then it's more of a purple. I mean, that's like a bright green, but if I go the other way, it'd be more of a, I don't know. We got to figure that out. So I'm thinking what I'm going to have to do is once I get all of this cleaned up, I'm going to have to put it back together and determine which way this is going to go on and then mark it. That way it looks right. Now, I developed a weird address problem. So it's like lines are jumbled up when they're not supposed to be. Anyway, so how do I know this is the right position it's supposed to be in? Well, if you look at the original film, see how the way it's degraded in the lines. Well, if we make the lines in parallel like that, if you look, it's in line with this. See, that's how you know. All right, so we have the film cleaned off. It's the old stuff's been removed. This stuff is blue because it's to counteract this green effect. Now, anyone that's looked at black and white LCDs has probably seen this green before. This is common. So what Toshiba did to get around that is use a blue film. It kind of cancels out the green. Now, so how do you know which angle to put this on? Well, I just figured that out. When this thing degraded into vinegar syndrome, you see these little lines right there? That's when it starts to break apart. Well, if you look at those lines and you put those lines straight in line with the LCD, so these lines are now straight in line with the LCD, just like this. Well, look. It lines up with this sheet because I think this is a 90-degree sheet. So because it degraded here, so bam. Now what I did was I put that sheet on there like that, and it works perfectly fine. Now, I've got issues, like I've got lines in here. You can probably see it. So if I try to block the light out, I don't know a good way to do that. Here we go. Yeah, you can probably see the lines in there. So I got to figure that out because that's the zebra strips. But I've developed another problem, like the text is kind of like jumbled up because I'm looking at the O for Toshiba. The O is cut in half and folded over in on itself, like I'm missing an address bit or something. But that's entirely possible because there's another issue I ran into as well. Because I peeled this film off, this glass panel now floats inside the bezel. And the problem with that is, because it floats inside the bezel, I can actually move the panel around so it doesn't quite line up with the contacts for the zebra strips. So I have to manually line the glass up and get the board in there and sandwich it together. So I could be slightly off on the left and right side because I can't really see it, right? The other problem is, because of that reason alone, I cannot put this film on here without this bezel on, because if I do that, if I trim this down and put it on there, and if I don't get it on there exactly right, then when I go to put the glass on it, it's not going to line up, right? So I have to cut this thing to size and mount it in the panel while this panel is put together. I can't do it any other way. It's unfortunate, but that's just how it's going to have to be. But yeah, and then doing the adhesive, because of the adhesive issue, I wanted to use like an applicator fluid like you would use for doing vinyl stickers and squeegee it on, but I can't do that because this metal frame is in the way, right? Yeah, it's a shit show, so there's not a whole lot I can do. But look at this cool effect. I can actually polarize the light, and you can see the text on the screen. Yeah, it's kind of neat. You can polarize the light and see. Anyways, okay, so that's what we got. Now I got to take this panel back apart so I can check the alignment and clean the zebra strips again because it's not quite right. So that's an issue. Also, this battery's not holding a charge. He said he replaced or rebuilt the battery, but when? You know, that could have been 5 years ago, 10 years ago. I don't know. I really don't know. But it doesn't hold a charge anymore. It kind of does a little bit, but then it drops off really quickly. So I got to get in there and check that out. But that's not a big deal. The battery works just enough to keep this machine running. Because the thing about this particular machine, it's just like the Macintosh Portable. It will not run without a battery. For example, if I unplug the battery and I go to turn it on, it won't run. Nothing's working. Just to prove what I mean, I'm going to take the polarizing film, put it back on here, and no, it doesn't work. It needs the battery. So, FYI on these. There's probably a way around it. I can build a battery eliminator, but I'll do that later. Not worried about that right now. What I am more worried about is this panel. So let's get this thing back apart and I got to go after the contacts over and over and over again so I can figure out, to try to get this cleaned up because I got to get it. Yeah. All right, so here we are. Here's what I've done. A little bit of deoxit D5 over there. I tried the alcohol method. It didn't work. I couldn't get it to work right. So I took a bit of the deoxit D5, which made this thing pretty nasty. And I scrubbed the terminals or the copper pads on the PCB, and I did the zebra stripes. Now we have a perfect LCD. Now it's running the memory test. So if I turn the contrast all the way up, there's no lines. It's perfect. So everything is booting as it should. No lines in the picture. Yeah, I don't know if you can see it or not, but no lines. So the next thing I got to do is I got to figure out how to get this film on here. So what I've done is I took and lined this up exactly where it needs to be based on where this is, which is close enough. So that's all lined up now, and what I did was I put a dot with a permanent marker here. I got a little silver Sharpie. This has got a protective film on it, so I can do this. So I made a little dot all the way around on each corner. Because what I'm going to do is I'm going to take my straight edge and I'm going to draw a line and I'm going to try to cut it. So that way I can get it to line up exactly right inside that device. Now, what I don't know yet is if I'm going to figure out, if I'm going to peel the film off and apply the adhesive on. I don't know if I'm going to do that yet, because the problem I'm going to have is, how do I get it in there? I'm going to have to do it with the metal bezel in place, because if I don't, I'm not going to be able to get the plastic perfectly lined, right? It's just not possible. So, and if I don't, then the screen, I'm not taking this thing apart again, because it was a pain to get the zebra stripes working perfectly fine. Wow, that is cool. Alright, so I got the film cut. I marked the outlines and I marked the center point just for alignment reasons. So yes. Now what we have to do is get this guy lined up. And I remember this is on the bottom because I made a mistake when I made a little bump there. So I should be able to do that. So now, this film has two pieces. Well, it has two covers. It's got the protecting cover here and here, just like a cell phone screen protector, right? So, we get one shot at this, so let's screw it up. Now, the thing about this, the correct way to do this is using an applicator fluid, like I mentioned earlier. Because an applicator fluid, you'd squirt it in there and it's just a liquid, and then this would float on the liquid. It also trap any little dust and specks and contaminants like that gets in between your phone screen protector. And then you would have a squeegee and you would just drive it all out, and as you're driving it out, it would mount it down. That's great and all, but we don't have a jig for this because remember, this is all lined up and the fluid will just get trapped inside and it would make a huge mess. And anyway, so we're going to have to do this the hard way. We're going to have to do this the way that everybody puts their phone protector screen things on. So, yeah, I don't want to talk during this because the last thing I want to do is spit saliva everywhere and get it all over this, right? Because that's a bad thing. So, pardon me if this section is mute. So here we go. So we're going to do that. And then I got a little piece of film here which I can use for, you know, cleaning crap. Which that's not going to work. That's garbage. Because all that's doing is just messing up the glass. Never mind. So what I'm going to do is I'm going to clear all this off. Clear you off. And then I have my glasses case here in this little zinny thingamadoogly dooder. Just trying to get it as clean as I possibly can. Streaks aren't really that important, but yeah, that's just, this has got lint in it. It shouldn't, but it does. I don't know the best way to do this. This is a pain. I'm just going to have to face the facts that this is not going to be perfect. Alright, here we go. I have enough film left. If I screw this up, I can make another one. But yeah. This isn't working very well. Nope, it's off an angle. That didn't work. I ruined it. That's not going to work. Nope, I have to make a new piece. Yeah, that's the problem. This is why you need applicator fluid. This is why you need applicator fluid. So, I'll tell you what I think I'm going to do. I wonder if this will work. Yeah, I gotta get this right. This is what applicator fluid is for. this allows you to do. Yeah, that's shit. Yep, I gotta make a new piece. I run at this one. This is why you need applicator fluid right here. Because this right here. See, now it won't stick anymore. Right? So. Yeah, this is bad for all kinds of reasons. Problem. Oh well. Anyways, you get the point. Well, unfortunately, it didn't quite go as planned. So I was able to peel it back up and lay it back down, and I used alcohol as kind of as an applicator fluid with a heat gun to try to heat it up and evaporate it, but it didn't come out all that well. You can see the bubbles. And when I peeled it up, things got trapped underneath it, but you see all the blemishes here? That's from peeling it up. So unfortunately, and then there's a crease here from peeling it up too. So unfortunately, I'm going to have to peel this whole thing back off and replace it again. But I'm almost inclined to leave it for now. Little piece of debris got trapped up in here. I mean, what do you do? There's a specialized fluid you got to have to lay this stuff down. And I don't know how to do that without getting it all inside this thing and taking it all the way back apart again. Well, this is the first time I've ever attempted vinegar syndrome repair, so for a first try, I don't think I did too bad. But, yeah. Anyways, it's not perfect, but it's better than what it was before, where we had, like, just, yeah. So, it's better than... I mean, I'll take it. This is better than that. I'll just say that. So, yeah, just grab a little alcohol, clean it up. And this is the matte finish. This isn't high gloss. I did that on purpose because I didn't want, you know, a shiny, reflective crap, you know. Anyways, that's what we got. It's not perfect, but you know what? The machine will be usable. So... we'll just leave it at that, and we're going to go ahead and put this thing back together. I do have enough to make another one if I want to once I get the applicator fluid, because I'm going to do an applicator fluid. There's no way I'm going to be going around that. But yeah, and I'll do that stuff off camera. But the point of this video was just doing it and getting this thing fixed. So that's done now. Perfect. No. Functional. Yes. So we'll take that, and we're going to start putting this thing back together and move on to the next one. Alright, so, okay, now let's get you. Oh, I thought I'd unscrewed that up for a minute. Oh, I was going to, yeah, actually, I did. Yeah, that's not right. No, I did screw this up. So, this cable... Alright, yeah, this thing is picky. I can't rotate this around. Well, I guess technically I could, but... No, it's not right. I can't do that. Grr! Gonna be a lot of footage to edit, because I think I'm gonna chop a lot of this out, but then again I might leave it. I don't know, because just like what other YouTubers are doing. I mean, it shows everyone in the world that I am human. I screw shit up. I screw shit up. I use profanity. I do all the normal human things that humans do. Right? So, like... Anyways... Alright. I do enjoy working on this stuff, though. As much as painful as it can be. I enjoy working on it. The cable likes to get trapped in these, but there we go. There we go. Seems to fit better that way. Huh. Weird how that works. So, alright. I was wondering why I was fighting with it off camera for a minute. Some fascinating machine to take apart and put together. And really, you don't even really need to take the hinge apart. The only reason why I did is so I could test the display outside of this whole mess, right? So it's easier to test the display when it's not in all of this plastic housing, which can get broke and, you know, stupidity like that. Because the last thing we want is the housing to get broken or marred up with a soldering iron, or, you know, just that fun stuff. There we go. There. Problem solved. Solved. Alright, so now it's gonna like plug this into easier. There we go. Much better. Okay. Now I gotta get the that in place. You know what I should have done, which I did not do? I did not test this display with the motherboard after I put the polarizing film on. You know what? We ball. That's what we're doing. We're just gonna roll with it. Fuck it, we ball. It certainly looks better. I mean, a well-lit room would be far better for a display like this. You know what I could do? Now, this is giving me some terrible ideas. But you know what I could do? I could peel the rear film off of this display. I know, stupid. But I could peel the rear film off of this display and replace it too, because it's still original. So it might have another problem down the road, but the reason why I want to do that is to get rid of the transflective film. Just put standard film in the rear, like just put a piece like that in the rear, right? And then use an EL backlight. So then I can actually backlight this machine. Wouldn't that be cool? I know that there's a T1000, no, the T1100. It's the same exact form factor, same display, but it is backlit. So, yeah, that would be kind of cool, though. I think. I don't know. I'm just spitballing. Yeah, I was polishing a turd. But, so this is the fun part. Getting this installed. Because I had a heck of a time getting this removed. And this is supposed to be a flathead according to the service manual. But instead, it is a Phillips head. Now, I have replacement double-sided tape, but I almost don't want to put that on here because I'm going to take this back off eventually anyways, because down the road, I'm going to do this display correctly instead of how it's done now, which is incorrectly. But all right, done. How's that? All good. Wobble, wobble, wobble. Oh. I don't like the way this thing has a crunchy sound. Okay. Now, here comes the fun part. So, the battery that's in this unit is no good. It won't hold a charge for more than like a minute. But it works well enough to run the machine. So, I think I am just going to leave it like that. Now, this has been an all-day adventure. So, I don't know. This thing's going to work. I don't know if the floppy drive works in this thing yet. There's a lot of things I don't know. Make sure I'm not hiding any screws. No, I'm not. Actually, I am. Back here in this corner. Yeah, I know. I just had this thing apart earlier today, but my memory span is like, nope. Sorry, no can do. There's literally hooks. There we go. There they are. Don't know if floppy drive works. So, yeah, about that. Nope. You're going to have to go here. And here. And then you go here. Well, that's fine. Because this needs a little bit of wiggle room to get this started properly. What the hell? Why won't that start? I think the screw is ruined. I know. Oh, I see why. It's off center. What the hell? I wonder if... I don't think so. The screw does not want to... There we go. There. The screw's supposed to be shorter anyways, but I don't see a shorter screw in this bunch. But it's fine. It's fine. It'd be nice to have a RAM expansion for this thing, but I'm hoping the service manual has a lot of that stuff documented. I don't know if it actually does or not, to be honest. Okay. That's done. That's done. Make sure I didn't miss anything. It doesn't look like it. I got 2 screws here and a third there, which I don't know where they go. Okay. Actually, probably go on the keyboard. Now that I'm looking at it. So we have, let's see, 1, 2, 3, 4, 5 that goes on the bottom. 1, 2, 3, 4, 5, and then there's a 6th one, which doesn't seem right. Alright, I'm probably going to be missing a screw somewhere, because I'm going to have extra screws left over, so yeah. Because there's only 5 of the long ones on the bottom. 6. There is 6 of them. That's right. So where do you go? This is extra. Extra screws. There shouldn't be any extra screws, but there is. Actually, I know why. Because I keep forgetting that the battery goes in here. Alright, that makes sense. Yep, that makes sense. There. Now before we get any further, let's power this thing on and make sure that we're good. Or not. Huh. Oh, you know what? Duh. I gotta use the right... Oh, no. It's been a long day, guys. Okay. Does it work? It does. Alrighty then. It's running the memory test right now. And the polarizing film works. I don't know if you can see it from over there. Let me check the camera. Yeah, you can see it. We're good. Okay, so let's see if all the keys work. Yep. Yeah, it's working perfectly fine. Slow. Does this have edit? Nope. Instead, it's probably got Edlin. No. Yeah. Hey, Chad.com. Edlin test.txt. La la la. Ignore. Ignore. Oh, come on. I don't know if the A drive works. Ugh. Okay. Yeah, we're fully functional. So, what is test? Diagnostic test. Let's run it. Test the floppy drive? No. Test printer? No. Alright, so now we're doing a system test. Wow, that thing looks good actually. Yeah, it's not perfect, but you know what? I'm actually happy with that. I can use it. I can actually see what's going on. The display is working perfectly fine. So, I'm actually happy. I really am. This couldn't have gone any better. Well, yeah, it could have gone better, but the first attempt is not bad at all. So there we go. Now, alrighty then. So, good enough. That works. CGA character set. Yep, everything works there. 320 by 200 graphics display. I think there's videos where they were saying this is pixel doubled, but I don't know. 640 by 200. Oh wow, that is so slow. We are not running it. We're not a speed demon. I'll just say that. Display page 0, 1, 2. Yeah, it's running. We are perfect. Alright, let's look at the system configuration. 2 floppy drives, 512K of memory. Alright, so we have that. Now, we have, let's see, didn't we have a DOS floppy? We did, didn't we? Let me grab the diskette that's in this, thing. Because remember, before we had this sidekick thing. So let's test the floppy drive, see if it's any good. Oh boy, I'm going to have to grease it. Yeah, no. You know what? I wonder if these have belts. Clearly, we got some more work to do. Because the floppy drive is all jammed up. So, it's all jammed up. So that's the next thing on our list is we have to take a look at the floppy drive. Alright, so I got the floppy drive apart. And we actually have a couple problems with this drive. So this lever here is got really sticky grease, so it's not really wanting to return. So that's problem number 1. Problem number 2 is, well, we got a bad leaky capacitor right there. You can kind of see it. So that's an issue. This is the same type of setup that the IBM PS2s used, some of their drives. And yeah, as I suspected, it's a Citizen drive, which has that 26-pin Citizen standard, which became the standard for a lot of laptops with the flat flex ribbons and the little tiny drives. So it's the same, it's just predated all of that. But if I free this arm up a little bit, I should be able to stick this back in here. I can. Yes, it all works, but then I'm going to have to try to clean that up and then get all this old goo off of that because it's just really bad. Clear that up, lubricate the stepper motor, and replace this capacitor if I can even get to it. Yeah. There's one over here I need to check. These are 4.7 bipolars, which I don't know if I'm going to have those. But I probably have these two, so I can at least change those. Next is I need to look at this little digital board here. and see if there's anything on this board that's a problem. So that means I got to take that out as well so I can inspect it, because that can also be an issue. Alright, so now we got to put the capacitors in. I removed the old cap, cleaned up the old flux and crap like that. So yeah, the leaky cap, one of the legs was completely broken off, so there's no way that capacitor was doing anything. So that is likely why we had a problem. So what we're going to do is just solder on the new ones like so. I had to take the spindle motor off just so I can do this. And then we have the one next to you, a big bag of capacitors. I keep a bunch of these low profile caps around because they're always used in literally everything that I work on. It's so crazy how often these things are used. So this one I don't have room because it's going to stab the coil of the motor, so we're going to pre-trim you, which is dangerous because it makes it hard to line these up. It just makes it more fun anyways. This was the same cap, but it wasn't leaking. Now both of these capacitors are 10 microfarad at 16 volts. So there's two of those, and these three are 4.7s bipolars, and I do not have those. So the next thing I want to do, before I get too carried away here, get that out of my way. Next thing I want to do is I want to check the switch. Now this does not have the high density switch, so this is only a 720K drive. So okay, that's normally closed. That's closed. So we're going to put the sidekick disc in here. Latches right in this time. Closed. Open. So close that. Take you. We're going to do you again. Open. Open. Alright, so that switch is fully operational. Everything's working good here now. Okay, now caps in, so the only thing left to do now is hope this thing actually works. And I want to clean this magnet off because I got crap all over it. Oh, leave it to me. Let's get the magnet dirty, Mike. That's what we need to do. You got to make sure this magnet surface is clean. Alright. There we go. Grab you. There's a little screw right there. Now some of these drives are a reverse thread. This one is not. Perfect. Alright, so that's done. The only thing left to do now with this drive is grab you, zoom spout oil. Because what I'm going to do, I could use grease, but just for now, I'm just going to do it this way because I've done it this way a few times. It doesn't need to be crazy. Get you a little bit over here, and then slide rails. There. So perfect. Next is we need to clean heads. You weren't terrible. Okay. No crazy belts to worry about like the newer drives. Because the T1200, the T1000 SE, it's got a belt driven drive. And those are fun enough as it is. So there we go. Quick little service of the floppy disk drive. Now comes the fun part, putting it back together. Which luckily there's not much to it. These are fairly simple to put back together. So we have these countersunk screws, which go here. Now I should just test this drive first, which I think I'm going to, but before I can do that, I gotta actually put a couple screws in here. Oh, gotta shut you off. I don't like leaving my soldering irons on. I just don't like it. Oh yeah. When doing the display, when you're trying to center the panel up on the circuit board, when you're doing the vinegar display or trying to fix it or whatever, it's 7 millimeters side to side on each side, and it's 4.5 this way from the glass to the edge. Measuring from the glass to the edge. That's how that works. Okay, so there we go. Now we need you. Okay. Now we gotta test it. And what I'm gonna do is I'm going to test it. You won't be able to see it on camera. You won't be able to see it on camera, but the hell did I do there? Whatever. So, the battery charge a little bit. We're going to grab you, open the screen back up. This is where I wish this screen had a backlight, but whatever. Alright. Here comes the fun part. Holy Discord, it's driving me nuts. Alright, so here we go. Not even trying. Well, what happens if I flip this switch on this side? No. The drive doesn't even do anything. That's unusual. It's not even really. Yeah. Strange. So that doesn't work. Let's flip it back the other way. No. What if I fail it? There we go. It's the B drive. So this is the B drive. Okay. Yeah, we're working now. I'm getting a directory listing. So this is the B drive. Oy. Okay. Let's flip you back the other way. Because there's a switch here that will switch the parallel port on and off, which allows you to use an external floppy drive. Yeah, it fails now. So it flip-flopped. So abort, fail, abort, A. Alright, well, I gotta turn the power off. See what it does here with that. Now it's working. Probably had to flip the switch and then do a reboot. Alright, so now it's booting the ROM. Let's grab the disk, A:dir. Hey, we got a disk. It's reading it. Perfect. That's fixed. So now we can get this thing back together again. Alright, so we're all back together. Let's end this video on a high note. Yeah, we know. So we're going to do a memory count, and then we're going to do... We have this Sidekick software with this disk, so let's do something with that. Get you in a floppy drive, A. Since it reads the disk now. I don't know. SK. Let's figure out what SK is. See if it even runs. Sidekick. Full system. Yeah, I don't know. Well, it works. Whatever it is. Works, whatever it is. So. I'm not sure. Oops. I was going to use the Linux command. Yeah, that works really well. Well, anyways, you get the point. Floppy drive is working fine. Everything appears to be working fine. So we are going to leave it at that. This has been a restoration video of a Toshiba T1000 that was sent in by a very generous viewer to the channel. And I appreciate that kind of stuff from the bottom of my heart, and I enjoy working on stuff like this. So if you have a comment, please feel free to leave one. Don't forget to hit the like and subscribe and all of that fun stuff. Until next time, guys, thank you for watching.